Hello everyone and welcome to our video. Hope you guys are pretty well. I am Shivam from SSRinfotech, and in this video session we will find out what is OSI model. So without wasting any more time, let's go ahead. The OSI model is a network reference model. OSI stands for Open System Interconnection Model, and it was created in 1984 by International Organization of Standardization, also known as ISO. OSI model describes how data transfer actually takes place in a network or internetwork from source to destination. One of the best gifts the OSI specification gives us is paving the way for the data transfer between different hosts running different operating systems like Unix hosts, Windows machines, Mac computers, smartphones, and so on. The OSI is a logical model, not a physical one. It is essential a set of guidelines that developers can use to create and implement applications to run on a network. It also provides a framework of creating and implementing networking standards, devices, and internetworking schemes. OSI has 7 different layers divided into 2 groups. The OSI model have top 3 layers defines how the applications within the end session will communicate with each other as well as with users. The bottom 4 layers defines how data is transmitted end to end. We can understand that user interact with the computer at the application layer, and also that the upper layers are responsible for application communication between hosts. None of the upper layer knows anything about networking or network addresses because that is the responsibility of the 4 bottom layers. 4 bottom layers that defines how data is transferred through physical media like wire, cable, fiber optic, switches and routers. These bottom layers are also determine how to rebuild a data stream from a transmitting host to a destination host application. The OSI reference model has following 7 layers. Layer 1 physical layer, Layer 2 data link layer, Layer 3 network layer, Layer 4 transport layer, Layer 5 session layer, Layer 6 presentation layer, Layer 7 application layer. Now let's find out what is the purpose of these layers. These OSI layers are most commonly used by vendors of network hardware, devices and software. They enable them to implement proper functionality of a network device and software, which then gives them easier interoperability with devices from other or different vendors. And one more thing to remember is that these layers are usually numbered from the last one, means that the physical layer is considered to be the first layer and application layer is the last one. And the most famous way to learn these layers is by learning a couple of mnemonics like all peoples seem to need data processing or please do not throw sausage pizza away. Let's move on and find out for what each layer of OSI model is responsible for. Physical layer do 2 things. It sends bits and receives bits. Bits come only in value of 1 or 0, a Morse code with numerical value. Cut. The data link layer provides the physical transmission of data and handles error notifications, network topology and flow control. This means that the data link layer will ensure that messages are delivered to the proper device on a LAN using hardware address and will translate message from the network layer into bits for the physical layer to transmit. The IEEE Ethernet data link layer has 2 sublayers. Media access control MAC defines how packets are placed on the media control for media access. Logical link control LLC responsible for identifying network layer protocols and then encapsulating them. An LLC header tells the data link layer what to do with a packet once a frame is received. LLC can also provide flow control and sequencing. The network layer or layer 3 manage devices addressing, tracks the location of device on the network and determines the best way to move data. This means that is up to the network layer to transport traffic between devices that are not locally attested. Routers, which are layer 3 device, are specified at this layer and provide the routing service within an internetwork. Data and route update packets are the 2 types of packets used at the network layer. Data packets are used to transport user data through the internetwork. Protocols used to support data traffic are called routed protocols. For example, IP and IPv6. Route update packets are used to update neighboring routers about the network connected to all routers within the internetwork. Protocols that send root updates packets are called routing protocols. For example, EIGRP, OSPF and RIP version 2. The transport layer segments and reassembles data into a single data stream. A pair of well-known protocols called TCP and UDP are integral to this layer. These protocols provides end-to-end data transport service and can establish a local connection between the sending host and destination hosts on an internet network. Services located at this layer takes all the various data received from upper layers application, then combine it into the same correct data stream. The session layer is responsible for setting up, managing and dismantling sessions between presentation layer and keeping user data separate. Dialogues controls between devices also occur at this layer. Communication between host or a client to a server is coordinated and organized via three different models of session layer: simplex, half duplex and full duplex. Presentation layer presents data to the application layer and is responsible for data translation and coding formatting. It is also responsible for translation services like translating old extended binary coded decimal interchange code EBCDIC and ASCII ASCII, the American Standard Code for Information Interchange, also pronounced as ASCII. Presentation layer also ensure that data transfer from the application layer of one system can be read by the application layer of another one. And some key functions like data compression, decompression, encryption and decryption are also associated with this layer. The application layer of the OSI model marks the spot where users actually communicate to the computer and comes into play only when it is clear that access to the network will be needed soon. So basically, the application layer is working as the interface between the actual application program and the next layer down by providing way for the application to send information down through the protocol stack, identifying the and confirming the communication partner's availability and verifying the required resources to permit the specified types of communication to take place also occurs at this layer. So that is all for this session. Now I hope it is clear to you that what is OSI model and how it is important to remind when things are related to computer networking. Please like, share and subscribe if you like my work. Thanks for watching. Warm regards from SSRinfotech.